Alright guys, welcome to another video, and in this video we will be looking at the libraries, the packages. In the previous module we had an introduction so that we don't just jump into the modules and into the libraries and packages. We had an introduction into the Python modules, right? So since we have looked at the Python modules, let's look at what we want to look at now. So we will be looking at the libraries and packages that we have, which are very powerful and important and core to what we want to learn. Okay, so we'll look at numerical Python, which is commonly known as Numpy. Okay, the numerical Python. What is Numpy? Numpy is a fundamental package for numerical computation. Key note the word numerical, right? It supports for large multi-dimensional array and matrices, along with a collection of high-level mathematical operations to operate on these arrays. That means we can do so much mathematical or numerical or arithmetic operation. Now, it's not just about that, but it is a backbone. It is core to other things in data science, but more especially Pandas. We're looking at Pandas after NumPy, so we have to learn NumPy before Pandas, because Pandas will be a build up of NumPy for us. So it's important that we understand what NumPy is. Why are we learning NumPy? Why is NumPy so powerful? Why should we learn it? It is fast, very fast. Why? Because it doesn't use, Python is a high level language, right? So, but NumPy is built with C, which makes it faster. C is a programming language. Okay, we have memory efficiency. It's unlike lists, right? The way NumPy stores data makes it consume less memory, and it is very rich. It has a lot we can do with it. It's almost I cannot use the word limitless, but it has more than enough that we'll ever want to use for it. Okay, don't worry if this is still seeming strange to you, like, okay, I don't know what you're doing, I don't know what you're saying, but once we start seeing the examples, it will start making sense to you. Okay, it will start making sense to you. Let me close what is Python, and then let's see how to start creating arrays. But first of all, before we can create an array, we have to import NumPy itself. So we'll say import NumPy. Now we can import NumPy, and that will mean, just like our modules, we have to do NumPy dot. But by convention, we have a shorter way of importing NumPy, and that's to give it an alias, right? We've used alias in SQ already, and it's still the same. Nothing has changed. Just say import NumPy as NP. So going forward, NumPy will be imported as NP. So if I hit enter, NumPy is executed. So throughout my session, regardless of wherever I want to use it, NumPy is available for me. I don't have to re-import it again. The only time I have to re-import it is if this session gets destroyed. Let's say I restarted the session, or I closed out of this browser and reopen it later. That is one time where I'll need to rerun this cell or re-import NumPy. Okay, so let's jump into creating different arrays. Okay, so we can start from list. So we can say list my list, which will be equals to, just a minute. So let's create some arrays. We'll expand this. Okay, so we'll type my list, and then we can say lists. We use the constructor method, and then we can grab a range of 1 to 10. All right, so print. So here we'll print. Hold on, come out of there. So here we'll do f then we'll say my list, so that we can see the difference between a list and a what's it called? So we'll see the difference between a list and a numpy. Okay, so we'll do my list first, and then later we will check how I will now see how to convert it. So we can just say my array equals to np. Now to call anything we want to use, we have to start with np. Okay, we have already imported numpy, so we'll just do np, then dot, and as usual we'll see a whole lot we can do with it. So we'll just say array. So once we have np.array, we'll pass in my list in there. So now that we've converted it to a list, we can now print the type. So my array instead, my array. So this will also be my array. Then we'll use a pipe. Then we'll do type of my array. All right. So this is what we have. Let's print it and see what it looks like. So we can see my list. Now, this is one reason why a list is faster than this is one reason a numpy array is faster than a list in terms of operation. Now, what are some of the key difference that makes it stand out? Let me just simplify it in the best way possible. For example, a list now, right? Each number right here, each number is saved in a separate object, right? Each number is a separate Python object that is just scattered in the memory, just like that, right? So, but for a numpy array, it stores all the number in one continuous block of memory. I mean, right? Just one. So there are no things like pointer, there are no overhead, just raw numbers, right? If you understand C, you understand some of these things I'm saying, or if you have a computer science background, you'll be able to follow, right? So and CPU loves all of this. Computer, you see they are processing the CPU, it loves all of this, right? So for example, again, in a list, there'll be type checking, right? Because if you have a list, you can have mixed data type. For numpy array, you have the same data type, in this case numeric, just like that, right? Another thing is majorly let's say things like vectorization. It doesn't loop over, it doesn't need to loop over. It is just so super cool. Of course, you can say there are some downside of it, right? Because numpy are rigid. You can't mix different data type, can append fast. No, they're just there like that. But just keep in mind, if you don't understand everything I've just said, just keep in mind that arrays are faster and better than a list. That's your takeaway. Okay. All right. From range. Now, you probably be saying, but we just used a range. No, this is a list range. NumPy itself has its own range. From range array. So I'll shorten array from range. I'll just do it this way. Then we'll say np dot. Now, it's not called range in NumPy. It is called a range. Now, it is not arrange. What do I mean by it is not arrange? When I say arrange, in terms of arrange like this, so it is a range. Okay, so we can now pass in the minimum value, the stop, just like we have in our normal range, right? In our normal range number. So let's do the same thing. 111. No step this time. Let's just print it. Print. I can just copy this. Copy this. Then you paste right here. Okay. Paste right there. Now let's start using some of our shortcuts. Now I want to rename these two variables at a time, right? Remember, Control Shift L. Now you can see it has highlighted both of them for me in one go like that. So I can just type array from range. So keep in mind Control Shift L. So when you copy and paste, you can easily just align things or change the variable names immediately. So we have this now, and then if I run it, Control Enter. So we're waiting for that. Runtime disconnected. It's connecting again. All right. So you can see it's exactly like this, but it is called a range. A range. That is what it is called. A range. Okay. This one is called a range. All right. So let's look at lin spaces. Array from lin space. And you're probably thinking, okay, what is a lin space in the first place? Well, from the word lin space, it simply means linear space, okay? And it gives you an evenly spaced number between a start and a stop. So let's just see it. We say np as usual dot lin space, np dot lin space, and you have a start. Okay, so we can say 1. We have a stop. We can say our stop will be let's say 20. Okay. We can add another argument, right? We can add another argument, but let's print this first and see what it looks like. So just copy this again, paste here, click on this, and then we'll say Control Shift L, array from lin space, just like that. Okay, so run this. Runtime is connecting again. Okay, it's still connecting. Just a minute. Okay, and you can see this is what we have. So it's giving us equally spaced number from 1 to 20. But then it seems like a lot at the moment. Okay, it seems like a lot at the moment. So what can we do instead? We can pass in 5, for example, and if we run this, it's just giving us 5 of those values: 1, 2, 3, 4, 5. Okay, when we don't pass in anything, it does it in a way that we can get the numbers. So let's say we want 7. We want 7 evenly spaced number between 1 and 20. You can see the first one is 1, the first one is 4, 1, 6, 6, 67, then the next one is this, the next one is this, all the way down like that. So that is what a lin space does. If I say I want just 5, which we did before, we can just keep it on 5. And this one says is what? A numpy nd array, and that's what I've been seeing so far. Okay, so yes, that's that about lin space. Now let's look at how to get arrays from the 0 arrays. They're majorly, or you can consider them placeholders, right? So you can just have series of 1s, series of 0s, just like that. And don't forget, quick one, that we are still looking at what? A 1D array. That means we don't have a row and a column in this case, just a single row of data is what we have been looking at. Okay, so just do np. So this should be array zeros, and that will be np dot zeros. Then we can pass in 5. We want array ones. Then we can pass in mp dot ones. We can pass in 5 as well. Now you're probably thinking, can we do 2s, 3s, 4s, 5, 6? No, we can't. We just have ones and zeros. But there's a way we can do it to also get ones, 2s, 3s, 4s, and all the rest like that. Okay. So, but before that, let's look at let's print this as usual. Copy this again. I think it should still be in our clipboard, so just keep it there. We'll rename the two of them array zeros, and then we'll paste it again. This will be array ones, right? So let's print the two and see what that look like. So you can see they're just arrays of zeros and ones. So what if we want to do arrays of threes or arrays of twos? Let's say array fives, arrays of fives. And say mp dot ones 5. Then we can do something we call broadcasting, right? So if I paste this down here, I can do this and say, hold on, array fives, just like that. So print this again, and you can see we're getting fives. So if you want any other number, you can just multiply it with that particular numbers. That particular number. Oh, see how I type this. Okay, this is capital NE. All right. No. Okay, yeah. So let's look at list a full and empty way of creating an array. Okay, so let's come here. So we can't cover all the different methods, but just a few for you to see. Okay, so you can say array, and then we'll call this full. So we can just say mp dot full, right? So you can see now. You see immediately it says the shape, the field value, the data type. So we can pass in all of that. So the shape, the field value, and then the data type. So we can say d type if we want. You can say that will be int, just like that. Okay, so this will give us sevens. So instead of doing it this way, you can do this. All right. So for empty array empty we'll say np dot empty. So we can just pass in 4. You can say the type is integer. The type is integer. Okay. All right. Now do not forget that for you to see the methods or options available, once you type it, right, just click out, come back inside there, and then you should see what that particular the arguments that you can pass in to the arguments you can pass into the methods that you have just selected. You can see, so it says shape, then data type, right? So let's just use 4, let's just use 5, and then we'll use d type as data type equals to integer. So we'll print the two of them to see what they look like. So if we do a Ctrl V, so let's rename them array array underscore full, and then if we paste again, and do array empty. All right, so this is what we have, and let's execute that. Let's see what we get. Okay, so you can see we have 7 7 7 7 sevens. So let's put in 5 here. You can see we're getting 5 5 5 5 5 5 5. You can see just like that. Let's put in 6 here. So we're getting 666. So let's put in back 7 that we have there. You see, this is what we have for the 7s. Okay, so let me put this in a new code cell. I'll grab this, cut it out, put in a different code cell, grab this, cut it, and put in a different code cell. All right. Okay, so this is what we have for this. And now let's run this. Array empty, array empty. Okay, so now what does the empty array do? It makes an empty array but doesn't fill it. It doesn't fill it. It's empty. Okay, it is empty. So what we see most times is just a block of memory, or if there's any junk in there or anything at all, anything there before. So if you notice that the first time we printed this, let me call this array empties, empties, empties. Yeah, I know that's not how to spell empties. Don't worry. We're just changing the variable name and then we run it. Oh, this is not supposed to change. This is the method itself. So we run it. I need to restart so that you can see what we have in there, right? So that I can see what we have in there. Majorly, they're not supposed to be values in here at all. Okay, so let's put in 7. Ha, good. So this is what we get. Is an empty array. So just grab some majorly, let's say the block of memory where the values are supposed to sit. We created how many spaces for us? 1, 2, 3, 4, 5, 6, 7. So that's what it does for us. It's just an empty array, nothing serious going on in there. So let's collapse all of this and jump into 2D arrays, because we're using more of 2D arrays for what we want to do. Oh, good. So we already have okay, just make it faster. So we have the arrays of 1s, arrays of 2s. So mp.array, this is the method. So I'll bring this down here to make things faster. So we have this, we have this, we have this. Bring this here. Now the only difference we have done, we have used some of this already, right? We've used some of this already. Okay. Oh, this should be like this. This like this. So like this first, and then like this. Okay. So good. This should come down. So you can just pause the video to type all of this out, or just basically it's just a change that we made. We only made a change. Now let's compare the 0s and 1s so that you can see the major change for a 2D array. Now in the 1D array, we only have it, we pass the value, let's say 0s, we only pass in a single value because it is not a row and a column thing. But for a 2D array, we have it as rows and columns. So that's majorly the difference. So for a 2D array, we pass in a tuple. So I'll leave this as matrix. I'll do this as 0, 0 matrix. This will be 1 matrix, 1 matrix. This will be full matrix, full matrix. Escape. This will be I matrix. This will be, okay, this is from a range. I'm already concatenating. Now this is from a random number. Okay, random number. So random matrix, rand matrix. We'll print everything out so that we can see how it looks like. This is from a range matrix. What else are we missing? rand and rand it. Okay, so rand it, randing it. Okay, so let's just walk through it together. So np.array, we're passing a list. We're passing a list, but this time we're not passing a list this way. We're passing a list of lists. Again, the major difference is, if you look at this, is more like passing this guy, Control C, into this place, array. Where is it? My array. So that's just what we're doing. That's majorly what we're doing. So you can see that this is a single list, not a nested list. But when it comes to a 2D array, we're passing a nested list. So we have a square bracket first. We have the first list, then we have the second list. Okay. So for the second one, we're passing it as a tuple. We're passing it as a tuple. So we want zeros of 3 by 4. We want ones of 2 by 5. Then full, we want it 3 by 3. Then you fill with 7. We can do the same thing with empty. We want an I matrix. We're generating from a range, and from a range it will be a 1D array. But with reshape, we're saying reshape it to 2 by 3. Now when we're using reshape, the rows and column, the product of the row and column must equal to the number we pass in here. So if we put in 7 here, this will throw an error because it can't reshape it to 2 by 3. Okay, so put in 6 there. Then we're generating it from a random number, right? We can see it says it's a random number generator. You can read through the documentation if you want. And we're getting the rand function. You can see, you can read the rand itself, what it does. The same thing with randint. You can read it up to see the difference between randint and random. All right. So let's print all of this out in a different code cell. So it's better that way. Let's print it out here. So we'll say print. Let's run this so that we can get easy control enter. Executed. Right. So we'll start printing. Print as usual. Okay, I think what we copied should still be there. Okay, we copied something else. As usual, let's go back and copy this guy. So paste it, Control V. So this will be matrix. Oops, matrix and enter. Okay, let's print that again. Copied space already. Control C. All right, Control C. Okay, so we'll change this to, this will change everything, but it's okay. This will change everything for us, and we don't want that. So let's go back and copy this guy from here. Can't you just type it? Yeah, I can hear your frustration, but it's faster when we just do it this way. So the next one will be what? Array zeros. Let's just memorize that quickly. So we have 0, 1 full I range. 0, 1 full I range. 0. Okay. 1. Full I. This will be I. Then we want range. No. Okay. Then we have rand. rand, and we have randint, okay, which is the last one. Anyway, just the major difference between the rand and the randint, as you should know, if you take your mind back just to a few moments ago or back to Excel, rand gives you numbers between, majorly rand itself, if it were to be a single, it gives you number between zeros and one, but majorly, key difference to take away: float, integer, rand int, integer, rand alone, float. Okay, so let's print all of these and see what they look like. Okay, so they're breaking because they are 2 by 2 anyway, so they're 2 by 2, so we're seeing all of this. So let me print one of them separately for you. Let's just print the matrix only, or let's just say matrix. We're not printing, let's just say matrix, so you can see what it looks like. And if you print it out, home, print, and run, you can see what it looks like. Now you can see how nice it is looking. So this is a row and a column. If you go back to the code, row, then column. So you can see 1, 2, that's the first row, second row. So it goes like that. If we want another row, we had it here. So row by row by row. This will be column 1. This will be under column 1, column 2, under column 2. So row and columns. So that is how it works. So these are just different ways. And if you look at this, this is a 3 by 3. No, 3 by 4. 1, 2, 3, 4. Right? 3 rows, 4 column. 3 by 4. And if you look at our code, 3 rows, 4 column. It is usually, do not forget that it is row and column, not column and row. It is row first, then column. So row and column, row and column. And yes, we have seen how to get some different ways of printing, of creating 2D arrays. So what about we now look at some array attributes, which are very, very, very important. Okay, so just pick any other array. So let's say we're picking let's create a new array. Let's create a new array down here. So we can just say new matrix, and then we'll say mp.array, and we'll pass in a list of lists. So for, all right, this is a comma, and then have another row. So they should be of the same 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's add one more. Okay, so we have 1. Okay, I'll just add a comma here, and this is what we have. So let's print it and see what it looks like. I'll print new array, a new matrix, I mean. So we'll run that, and yeah, this is what we get. We have a 3 by 3 matrix. Okay, row and column is 2D. Do not forget row and column. So what are the important things we can get about our array? The first thing we can get is the shape. So new matrix dot shape. Let me just print shape of our data. So I'll just keep it on shape only. Just keep it on shape only. Colon. Then we'll say new matrix dot shape. And you can see right there. So let's print this and see what it looks like. And you can see shape says what? 3 by 5. 3 by 5. That's 3 columns, 5 rows. So let me print that again with some space. All right. You can see 3 by 5. So let's just print out some other attributes like that. We want to see the dimension, right? We want to see the dimension. We can do that as well by saying print. We'll put our f \n. Yeah, okay, it will be easier with this. We have to change the name as well. Let's just type this time. All right, so dimension, or not dimension, axis. Let's call this axis. Then we'll say new matrix dot ndim. Now if you look at this ndim, okay, next one, let me just paste a few times. Let me just paste a few times, and we'll say dot size. We'll say data type. We'll say item size. Yeah, we have item size. We can check. What can we check again? We can check number of bytes. Well, there's no need to do that. We can transpose it. Right, we can transpose it. You can see capital T does the same thing as the full transpose itself. Okay, so transposed matrix. So matrix shape, matrix size, then once matrix data type, we can just do the data type in this case, item size, item size, or item size, anyone. So this is just a few. Let's run them so we can see. Okay, am I putting space right? Notice that. Okay, let's run that again. So the shape, the axis, right? We have just two axes, that's row and column. So y-axis and x-axis. So matrix size, that means the total number of elements in there, right? It counts the total number of elements, and that's 15. Y is 3 by 5, so 3 times 5 is 15. Data type is integer, 64. The item size is just 8, which is just bytes per element. Actually, it's just the byte per element. Okay, item size, let me put into brackets, bytes per element. One single value is an element. Okay, one single value is an element, and we can get total bytes. Since we're checking for this, we can as well just print the total bytes. So we can say total size, and this will be no longer n item size, it will be n bytes. All right, so on transpose, which just gives us a transpose version of what we want. Let's run that again. So you can see, so this and this gives us this, and you can see the transpose version. Before it was a what, a 3 by 5. Now it is a 5 by 3. Transpose basically means row becomes column, column becomes row. Okay, the shape changes, right? The shape changes. Now if you compare, how did it do it? And let's see, 1 2 3 becomes row 1, 1 2 3 becomes row 2. Come off there. 1 2 3 becomes row 3. So column become rows, rows become column. So that's what we have right there. All right, so we've seen different ways of getting the 2D arrays. Now we can start some indexing and slicing. Okay, we can start some indexing and slicing. All right, so let's open this up. Now, accessing elements or sub elements of an array is similar to Python, but it has more multi-dimensional capability. Okay, so we already have Numpy, so we don't need to import Numpy again. Okay, let's save and reload quickly. Just wait for that to finish. Okay, file is now saved. Let's take this out. Oh, okay, I think it didn't save, so it was what we just created that went out. All right, let me see the last file we have. Created a new array 3 by 3. Okay, so we'll be using this new matrix. Okay, we use it for the attributes. Yep, that's for the attributes. So just print new matrix in here. So let's just print new matrix. Print new matrix. Okay. All right, we're connecting. Should be up soon. Okay, so this is what we have, and then we want to start accessing a single element. That means a row, in a column. Then we slice rows, then we slice columns, then we do other things. So, but let's start from the very basic part of it, and that is elements. Getting elements are individual values in an array, right? So let's say we want to grab 0. Let's say I want to grab 0. So we know, I think we should print this separately at the top so we can always reference it. Then we'll have this, Control Enter. Okay. Now inside here we want to get the first one will be the row. So let's say I want to grab something from row 2. Yes, this is row 2. Do not forget it's 0, 1, 2, the indexing of the rows. So this is row 0 for the first row, row 1 but the second row, row 2 but the third row. Row index 0, first row index 1, second row index 2, third row. So say the row, then we'll put a comma, then we'll put the column. So we want to grab 0, so that will be 3. So we're saying the index 3, 0, 1, 2, 3. Okay, 0 is 3, 1 is 2, 2 is 7, 3 is 0. Oh, 0 is 3. Yeah, no, 3 is 0. Yeah, okay. Yeah, so that's what we have. So let's print this. So you can see we print out what? 0. So now there is a faster way to do this. Of course, we cannot tell looking at it only. Okay, we can't tell looking at it only. But what faster way is there to do it, right? You can say, let me bring this up. You can say, close it this way and close it this way. Why is this faster? Once you grab this row, it doesn't do a lot of checking again. It just runs through this one. But of course, you might not be able to tell looking at it physically, but this is quite faster, and yeah, very good. But so far, or going forward, we'll just stick to this. But as a good practice when you're working on big projects, why would I stick to the first one? Because this is a more general convention you see. Okay, it's a more general convention you see online. But keep in mind, so if you see me do it this way, it still works perfectly as well. Okay, it works perfectly as well. So yes, now try grab one. We'll do this together and then you can start trying to grab different elements that we have. So we want to grab one. It's on the second row, second index row. So oh, how did it jump there? So that's 2 and that's 0 minus 1. And you can see we're just using the negative indexing to grab it since it's the last value, or you can count 0, 1, 2, 3, 4, and then you pass in 4 right there. So if you pass in 4, we get the same thing, absolutely the same thing. So feel free to grab individual elements just like that. And then let's look at slicing rows. We have been able to grab individual elements. Let's see how we can grab full or entire row. Okay. So let's say we want to print out a row is this way, right? So new matrix, then we'll say row 0, and we need, now just like that, it has grabbed it, everything. We don't need to, now when we want to use, we can pass this in and say, put a colon and say everything, okay, and say everything. But as usual, it will be like this, okay. If we're using a single row, okay, it will be like this. Now let's quickly take a quick back step, a step back, right? Let's take a step back. Now I mentioned earlier that this is the convention you see online, and majorly that's what I will use most of the time, but just keep in mind that I might decide to use it, or I can intermittently switch between the two of them, or stick to this. Anyone you see me stick to, just don't get it confused. It's still the same thing. It's either you have it in a single square bracket separated by colon, separated by comma. So anything that happens here, for example, if I do this, so everything here is for the row. If I do this as well, everything here is for the column, separated by comma. Or I can just have them in two separate square bracket like this. Okay, so just keep that in mind. I'm saying that so that I don't get confused as we proceed. Okay, so let's come back here. We have been able to grab the entire row. You can see nothing changed. So if I just put in a single value, it grabs only the row, right? So for the column, if I want to grab, let's say, the first column as well, that's 2, 3, 9, I can just say print, and just copy this, and then I'll put a comma, empty, then I'll just put in 0. So that means I'm saying anything before the comma, which is meant to be the row, and then pick the column only. So we have to pass in, now the first thing is that which row or which column, which column. We have sliced the row, so we're slicing the column as well. So this is giving us a single element. So what exactly do we want? We put in a semicolon here, and we execute the code. Execute that, and yeah, now we're getting the first column. So this at some point might slightly seem spiced up, okay. So since this is more of a beginner video, as much as it's more intensive, right, it is considered still a beginner video, and I'll stick to this simple version so that I don't get confused along the way. So I'll stick to the comma version of what we're doing. So this is how we pick a single column. So what if we have what if we want to pick the last column? So we can change this to 4, and then we'll execute that, and then we're getting 311. Okay, so 311, that's how we tell it to grab. So what if we want to grab both rows and columns, right? We want to grab more like creating a subset. Okay, we want to create a subset. So we just come here and say matrix matrix subset. Okay, and here we can say this will be a new matrix, and then we want to get close. We want to grab. So how do we grab it now? Let's print this guy close to us again. So we'll see what we have just at the top here. Paste it, print there. Okay, so let's say we want to grab this into a new subset. That's 327, and then okay, let's pick what is in the middle. 270, 876. Okay, so that will be what? Row 2, row 1 to row 3. Why? We know that the last number is not inclusive. So row 1 to row 3, and then we want to grab column 1 to column 4, right? We want to grab column 1 to column 4, and yes, we'll print this now. So say matrix subsets. Oops, that's, oh, stop jumping. Matrix subset, shift subsets. Okay, let's check again. Matrix subsets equals to this matrix, and then we're printing the subset. Okay, good. So we'll execute it, control enter, and yes, we have 270, right? 270 and 876. So I've been able to grab that part of the code. So let's grab something else. Let's grab just 0161. Let's grab 0161. So this time we'll just print it directly. Print, Control C, Control V. So in a quote, I want a \n, so we'll just have a single space there. Then I'll use a comma like that. So here we want row 2 and 3. So that's index 1 to 3. Don't forget that the row index is 0, 1, and 2. We're adding 3 because it will be exclusive. So we're grabbing row 1 and row 2. Row 2 and row 3, just the index. Okay, just the index. And then we want to grab, this time we're grabbing only 4. So put 4, then 6, just like that. Put 4, then 6, just like that. So you can see 0, 1. So this is 0, 1, 2, 3. 3 rather. 3. That's 3 and 5. 3 and 5. And you can see we have grabbed 0, 1 and 6, 1. So you can start practicing how to slice different parts of this array. Very, very important. Now let's jump into the next one. I don't need this. Let's jump into the next one, which is Boolean filtering. How to filter data. And you see, the cool thing about this particular Boolean filtering is that it makes data filtering easier for you. You can easily filter data with what I'm about to show you right now. So we'll start with how the basic is before we now combine it in a single line, right? It has nothing to do with combining conditions, but let's look at what I'm talking about. So we have a matrix. So we can say even matrix, even matrix, even matrix, even matrix. Then we can say for the even matrix, we want to say where our current new matrix, all right, modulus 2 equals 0. Now what we'll be seeing is true and false. So let's print it out first to see how it works. Print even matrix. So run this, and you can see we're getting true, false, true, false, true, false. if we compare this to our matrix itself, I think I should just bring this matrix down. Okay. No, it should go up. Okay. Okay, it should go up. Yeah. Now, if you look at this, 2 is an even number, so we have true. 4 is an even number, so we have true. 5 false, true, false. So that is how we mapped everything. So it is very important. Now, this is not how we use it because we don't want to see true and false eventually in our data. So how do we actually print the results? So this is more like a sub step to doing it. But what is the best way or right way of doing this? The right way of doing this is to pass this in directly this way. So here we can now say new matrix, then square bracket this. So it only returns the values that are true. So I'm saying new matrix, then filter even matrix out of it. So let's run that and you can see it is only returning the even numbers. It's only returning the even numbers from our list, right? So what best way would we have done it? It is meant to be this way. Even matrix beta, okay, will be new matrix in a square bracket all these conditions we specified outside. So we'll copy this, Control C, and paste inside here. So everything just goes inside the condition there. And if we print new even or even beta matrix, even matrix beta, we want the beta version. Okay. If we print this now, you can see what we get. Exactly the same thing, no difference. So going forward, we'll do it on a single line like this. So we don't have to do, I only showed you this so that you can see the underlying what's it called, the underlying way of doing it. Okay, so the underlying way of doing it. So let's print even matrix as well. All right, so you see the boolean, the true false, then it filters it out and you're getting this back. This will also be useful for us when we get to pandas, right? As we said earlier, Numpy is built, or pandas is built on top of Numpy. So we're learning Numpy first so that when we get to pandas we can do much more with it. Okay, so this is what we have. Now we can combine condition, we can change them as much as we want. So what if we want to see, now we said we want to see numbers, even numbers, and want to see all the numbers greater than, let's say, 8. Why? So that we can get 9 as part of our results. All we have to do is, we can, now this time we'll just print it, we'll not save it in any variable. So we'll just say new matrix, we'll open a square bracket. Let's just close our print bracket first. So inside the square bracket, we'll pass in our conditions. So we want the even numbers, right? This is the even numbers. This will give us the value of the even numbers, but we should not put this in square bracket again. Okay. Then we can say and, right? If we want it to be and, then it checks both. For and, it must satisfy the 2 conditions. But for or, it just has to satisfy 1. So since it's satisfying 2 conditions, we can say it is an even number, and let's say for example it is divisible by 3. So let's start with that. It is an even number, so we use the and sign, then we'll say it is divisible by 3. And how do we specify that it is divisible by 3? We'll say new matrix, and then we'll do modulus 3 equals 0. Okay, so that's what we have. For the or part of it, we'll just change it to the pipe symbol, and then we'll say new matrix greater than 8. Okay, we'll take out this part of it. All right, so this is our hand, this is our or. So let's just put a comment, print even numbers that are divisible by 3. Even numbers that are divisible by 3. Okay, good. So let me just put this at the top instead. All right, just like that, and just like that. For the other one, you can just put the comment in front of yourself. And what would the comment be? The comment would just be that, okay, I think this jumped out somehow. Is that it prints even numbers and values. Okay, let's use odd numbers this time. So this one prints odd numbers and values greater than 6. So that means any value greater than 6, for example, we'll see 8, even though 8 is an even number. All right. So print odd numbers and numbers greater than 6. All right, so this should be numbers as well. Now there is a little challenge here. Okay, and the challenge is that when we are combining operations, there is something we must do. Okay, so let me run this, and you can see, ooh, we're saying the truth value of an array is this, is ambiguous, all right. So what we must do is that we must pass individual condition in a parenthesis. Pass it like this to make it unambiguous. Okay, this is another condition. Open a bracket, a parenthesis, close it, so you can see each condition is now sitting in a parenthesis, which makes more sense, and it will even make the code more readable, right? Just like this. So if we run this again, now we are getting everything nice and smooth. So if you look at this, it is saying we want to see values where if you divide them by 2, the answer is 0. And now it included 0 for us, right? It included 0 for us, but we want to exclude 0. We can say and. Now when you divide anything by 0, what do you get? So that now, because you have to think about that first. If you think about it, when we divide something by 0, what do we get? Then we can now write a condition for that. But anyway, we don't need to think much about how or what that will get us, or mathematically when you divide by 0, what you get when you divide something by nothing. Okay, so that is not that should be undefined, right? So now we can just put where array or new matrix. All right, so where new matrix is greater than 0. Okay. So saying when new matrix is greater than 0. All right, do not forget that in the efficiency part of our code, we allowed our line of code to break into another line, right? So that's why we're having it this way. It's still on a single line, but instead of it overflowing all the way to the front and then we keep scrolling back and forth, it just comes there. If you don't remember where, you just go to settings, you go to editor, then you see it says where now code folding, code wrapping. Okay, so that's what we did. All right, so let's print this now, and you can see it has excluded 0 for us because we changed all the three conditions, and all must be true before our results can be true. So even though 2 is an even number, we do not want to see 2, right? We do not want to see 2. We want to see numbers that are even and also divisible by 3 and are not 0. So that's how we change the condition, and it looks neater, and you can keep adding more conditions just like that. And for the or part of it, we're saying we want to see all the odd numbers and any value greater than 0, because if you look at 8 is not an odd number, right? But we are using or. So it's either you show me this or show me this. So you just grab from both sides of our conditions. All right. So yes, and we have quite seen a good we now have a good foundation of NumPy. Yes, going through the video first time, you cannot put everything into your head. You probably need to take a step back, practice, think. That is where the retention comes in. If you're just typing the code passively, you will not learn anything. You will not be able to retain the knowledge. So I will advise you, open a new code cell, add a comment, or I'll calculate this or do this. Type what you want to do and start writing the code. Now that way you force your brain to retrieve the knowledge you already gained, right? It will be difficult the first time you're trying it because it will seem as if you don't remember. So stay there for a little while. The struggle, that moment of struggle, is part of your learning process. So stay there a little while because it eventually strengthens the neural path to that particular information or knowledge. Okay, so it is the best way to learn. Do not learn passively. Do not just take everything in, take everything in. Just go over it again, that particular part. We're not done with NumPy, by the way. We're not done with NumPy, but just go over that particular part, take it in slowly, and then continue with the rest of the video. Okay, so we want to look at basic operations in NumPy, such as element-wise operations, broadcasting, and the likes. Then we'll now jump into some statistical options for NumPy as well. Okay. Now, quick one. Element-wise operation versus, I'll just put scalar here. Scalar operations. Scalar operations. Scalar operations. Now, what is the difference between element-wise operations and scalar operations? Now, for element-wise operations, it happens between two arrays, okay? But for scalar operation, it's just one array. Think of scalar operation as when we did MPs.zeros, MPs.1, and we wanted fives, right? Without using full. The only way to get fives, that means a single array of fives, is to use mp.1s times 5, right? Or multiply with any number that you want to get. So that is a scalar operation. But for element-wise operation, you have them as between two particular variable. Okay, you can do addition, you can do subtraction. Okay, we'll just do a few, then I'll list maybe a few for you, then you try them out. However, most of them will follow the rule or the law of matrix. Okay, so let's create two example. Let's create two. I think I actually need that, so Control M A. No, I want it inside here, so that should be Control M J. Okay. I have to cut this part to shine. Jesus, what happened? Control Shift Z. Oh, it's still recording on shirts. I have to like indexing and slicing is gone. Basic array. Okay. Oh, okay. This thing changed. Try to look and see. Well, I don't know at what point, but it's okay. We'll deal with that. So let's create two arrays in here. So we can just, I think we have a subset. Let's print our subset. Or let's just create new two arrays quickly. Mat A, that's matrix A, and then matrix B. All right. So with these two arrays, we'll just put in different values there, and then we perform some quick operations with them. Okay. We'll keep it simple and short, so nothing too big, just for us to understand the key thing. So we'll do mp.array, mp.array, then we'll pass in, let's just say 10, 20, sorry, 10, 20. Okay, and then for the second one, which will be a matrix B, we'll do mp.array, then we can just do 3, 4. All right. So these are the two arrays we'll be working with. Let's execute them. Okay, they have been executed. So we have quite a number of options. We can do addition, subtraction. So I'll just do mp.add. Okay, mp.add. And then that'll be matrix A, comma, matrix B. Okay. So next one will be subtract. Subtract. Do not forget the dot notation can give you all of this. Subtract. We can do multiply. The next one we can do divide. We can do floor divide. Remember that all of these things are available as operators, right? All of them are available as operators. Floor divide. We can do exponential. Let's just do that after multiplication. Power. Mat A. Mat B. We can also do remainder. So that will be after divide. So mp dot remainder. Oh, keep typing again. Mat A, mat B. Okay. So do not forget that all of these operators are available the way we can use them. This is plus, right? This is minus. This is asterisk, double asterisk, all the way down like that. Okay. So let's just see what the results of this will get us, and then we now look at what they do. Okay, we didn't have print, so let's activate multi-cursor. That's alternate and click. Just hold the alt key and then click. All right, so I'll just do a print. Then I can jump to the end. I have to close the bracket one by one because they are not the same level. And I just hold alt, alt again, alt again, alt again, alt again. Then we'll close the brackets. Okay. So all brackets closed. So let's print them. And we can see the first one is giving 13 and 24. So addition, 10 plus 3, 20 plus 4. Mat addition. You can use just mat A plus B. It does the same thing. Okay. For subtraction, that's 10 minus 7, 10 minus 3, 20 minus 4. For multiplication, 10 times 3. So like this, like this, like this, like this, like this, like this, all the way down like that. Okay. For division, for remainder, if you look at the remainder, what are we getting? Now, we're getting 1 and 0. Because if you divide this, 10 divided by 3, that should give you 9, remainder 1. 20 divided by 4, that should give you 5, remainder nothing. Okay, remainder nothing. And yeah, these are some basic operations we can do with NumPy. Just before we move on, let's see a 2D example, 2D array, so that you can also get comfortable with that. So we can just say A maths A 2D. So this time we just copy this. Okay, let me copy all of this. Then we'll just modify it right here. Okay, maths A 2D equal to, then we'll post in another one right here. A list of lists, don't forget. Then we'll say 30, 40. Okay, so we have a list of lists, the same thing for this. Then we'll pass in another one, open the brackets, and then say 5, 6. So we'll use operators this time just to test things out. Let's just do that here. I can just say print maths A 2D plus maths B 2D. Okay, 2D. We'll change this to 2D. All right, and then we'll do a subtraction as well, and okay, so you can try for other ones as well. So if you look at them, see what we have here. So let me just add a line break at the top, \n to the arrays. So this one can be 1D arrays, okay, 1D arrays, just like that. So print it. So we have 1D arrays and we have 2D arrays. So you can see the addition of what we have in here. So if you look at this, let's quickly comment all of this first. All right, so that our answer will not be far from our value. Don't forget that this is row by row, right? So 10, 20, 30, 40 below. Then we have the first one is what? 13. So that's this adds this, 24. This adds this adds this adds this, right? So we have 35, we have 46. So that's how it happened. Subtraction as well. And now when you start going into the multiplication and other things, for multiplication you use the dot. Okay, you use dots for that one, or use the at symbol. You use the at symbol, not generic multiplication, which is asterisk in this case. Okay, all right. With that, we can now look into scalar operations. Now for scalar operations, which are just a single array, right? Like I said, they're just a single array. Then you are doing some kind of broadcasting operation in there. Now, so far, quickly just to take you back a little bit. Now, if this were to be a list, right, you will notice that for us to do things like this, we'll have to loop over it. Do you remember? So we have to say for every number in this matrix, then divided by 2, we have to use a for loop, right? But because we're using an array, it is so powerful that it handles it smoothly without looping, right? That's how powerful it is. The same thing with the broadcast operation I'm about to see. We don't have to loop before we can just take the square of numbers, for example. So let's say array. So we can say my array, or mp.array, mp.array. Then we have a list of 1 to 10. Let's just do a range. Let's do a range of 1 to 10. We can say array squared. Okay, array squared. And that will just be array times array, or array times 2. So array times 2. So array raised to the power of 2, I mean. So if we print array squared, array squared sqrd, yep. And right above it, we want to print array itself. So this is a single line operation, right? You can do addition, you can do multiplication, you can do division, and you can see 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100. Just like that. One single line. No loops, nothing. That's how fast it is. And yes, we have seen a good basics of the operation of NumPy. Now we can jump into the statistical operation for the same NumPy. So let's see what we can do with statistical operation. And yes, we're close. We're just very close to the end of it. Stick to the end so that you can see what we have in here. Okay. So now we're looking at the statistical operation. We already have this data already that will be used to make it faster. But let's look at, let's just what does NumPy do for us statistically. Now, unlike when we're using the module where we have to import the statistical module, in this case NumPy has it as part of it. So that's why NumPy is a library. It has a whole lot in it that we can do with numbers. So we'll just look at some few things, basic one, for example, mean, median, all those basic things. We'll look at that and then we'll move on to the next thing. Okay. So let's run this first so that we'll have our data ready. Okay. Now it's loading. So while we're having our data ready, let's see some few things we can do. Well, can do \n. Let's print the original data itself. Okay, no space. I do not want any space, so it doesn't look weird. Original data. Then we can say start data. Okay, so that's the original data, and then we'll just copy and paste this a few times. Then we edit it. All right, let's stop here for now. So we'll say mean, and then that will be start data. Now, just before this, we'll just do mp.mean, mp.mean, like that. The next thing will be median, mp.median. Let's just type it out. Median. All right, just like that. Mp.median. So what other thing can we see? Let's say standard deviation. Let's bring the standard deviation. Okay. Now all of these things we'll still see. There will still be a video dedicated on them. Python for statistics. Okay. So this will be np.std. Okay. std, go all the way like this. Standard deviation. Let's check the variance. variance, and we'll do np.var as you've probably thought about it or guessed it. np.var. This can also be like our data profiling, getting to know our data and all of that. But of course, there are some other things we could have just used, but this is more strictly statistical. So minimum, maximum. Okay, let's do minimum so that we can know the minimum value. Minimum, it's a mom. Then we'll do a maximum, and finally let's just say a sum. We have way more that we can do, no doubt, but use the dot notation to find out more and more and more that you can do with them. Okay, maximum np.max, np.mean. Okay, now I think we're good with this. We're good with all of this. Then we'll print them. So we can see original data. Mean is 13.9. So if we want to round this up, to our decimals, let's say 2 decimals or 3 decimals or 4 decimals, we just have to put it outside this place. So let's say, for example, 2f. Okay, and we'll run that again, and you can see it's now showing as it's just adding unnecessary zeros for our mean. We put on 3 there, getting 3. Oh, okay, 2. So I missed the dot. Then we'll do this. So we're getting 9.0. Okay. All right. So mean is 13.9 as the average of these numbers, the median 13.5. So you can see that in one go we can easily get all of this without calculating manually. This is the standard deviation. Okay, so for standard deviation now, we can do a 2 decimal place, colon first, full stop, 2f, variance as well. You can do that for variance as well, colon first, full stop, then 2f. So if we print it again, you can see what it is now. So 13.14, 9.89, minimum is 10, maximum is 20, and the sum is 139. So majorly .var. So just feel free to try out as much as you feel need to, but these are major ones that you probably need. Now if you need them for some advanced operations, you can just search Google or just use the dot notation, as long as you know what you want to do, right? So let's say, for example, just do np dot this. You can see we have the course. If we say we want to do, we have the tan. So they're all there. They're all the engineering, whatever it is, just search for it. Numpy has it for you. Okay, Numpy already has it for you. Now let's look at for 2D arrays, right? So far we have used a 1D array. So for 2D array, let's see what we can do. Because now the word axis wise means, is it, are we perform the operation across a row or across a column? Okay, so let me bring this down here. Now let's just create a new one quickly. So we can call these 2D. We can start with a number. So say start 2D data, or start data 2D, whatever it is. So we'll do np.array, and then we'll go with a list of lists. So the first row, 1, 2, 3. The second row, 4, 5, 6. The third row, 7, 8, 9. Okay, so 7, 8, 9. And print the original data first as usual. Now, to make this simpler, we can do a range. Okay. So a range of 1 to 10. Okay. And then we'll do dots reshape. So reshape 3 by 3. Okay. So it's faster or better this way. Then we want to print the original data. Let's just copy some values here. Control C, Control V. So in this case, we just want to do, for example, we want to print the original data first. So original data 2D underscore. Then we can say we want to check the mean as well. So we can do the mean 2D of all elements. This is elements wise now. Now let's say we want to do an axis wise. I think I'll just want 2 more. We'll just keep 2 more. Okay, so others will be out. So let's say we want to do a mean across a column, across a single column. Okay, so we want to do a mean across a single column. All we have to do is to specify the axis. All we have to do is to specify the axis, and that's the difference maker. How do we do, or how do we specify the axis? Okay, I can just recopy this. Since this is what we want to use, I'll paste this twice. Control V, Control V. So in here, I'll just say column mean. So let's say column mean first. All right, column mean. And then we'll say row mean. Column mean means mean along the column. So we'll just do axis. So after passing the value, we'll say axis. Now this is no new. It's not anything different. You probably ask, how do you know all of these things? Like I said, and always make emphasis on, you can even learn, or you can go deeper yourself. Just type it in. Now you can see that immediately I started typing. And once you type in the np.mean, open the brackets, you see the documentation. You can see the documentation string, and you can read everything about it to understand or have a good idea of what you can even do with it that I might not have shown you. Okay, so you have the axis, it says none. You can also add the data type. You can add different things that you see here. So axis, I'm not sure what I've typed. Okay, remains x s. So say axis for column, we put in 0. Okay, for row, we put in 1. So in this case, we'll do axis equals to 1. All right. With that, we can now run our code. Let me check. Yeah, good. Okay. So you can see we're getting the mean, the average of all these numbers. Right. You can calculate the average yourself. And then you can see the column mean. Now, let's look at the data so that we can understand what the column mean is talking about. We have 1, 2, 3. Then we have 4, 5, 6. Then we have 7, 8, or 7, 8, 9. Yeah, 7, 8, 9. 1 for the column, 1 plus 4, that's 5, plus 7, that is 12. That's 5 plus 7, that's 12. Now 12 divided by 3, you get 4. So it's doing it across the column, or down the column. Yeah, let me use the word down the column. Across a row, down a column. So the second one is 2 plus 5, that's 7, plus 8, that's 15, divided by 3, that's 5. 3 plus 6, that's 9, plus 9 again, that's 18, divided by 3, that's 6. So across or down a column, across a row. 1 plus 2 plus 3, that's 6, divided by 3, that's 2. So you can do the rest and you understand what this means. So we specify the axis to get what we want. So 0 axis is column, one axis. Axis 0 is column, axis 1 is row. Keep that in mind, okay? So you can do your calculations across different axes of your data, okay? So let's collapse this. And here, when we look at the last part, before you now see the exercise reserved for you. So let's just look at that quickly. Let me take out this. Just be numpy. Yeah, this is numpy already. So I'll just keep it this way. Okay. Oops. Keep this way. All right. For others, this is just the first example on how array is faster than a list. So we have a list of number 1 to 3, and then we are looping over. For example, we want to get the square of that number. I think we did something similar just now. We left it this way so that you can understand the difference. Now, but we've covered it properly already. So for a list, we'll have to loop it to be able to get the square of those numbers. Or we can do something like a list comprehension. Now, a list comprehension is where we have this and we say x or x times x, right? X times x, then we'll say for x in let's say a range of number, or in our number list, right? So first of all, we'll do x colon. So then we'll say for x in this, and then we'll loop over it for a list comprehension. So in this case, we're just what? We're getting the list, we're looping over it, and we're multiplying each number by 2. But for Python, for the NumPy, we just do times 2. So no looping. So let me just keep it like this on your screen. Take a pause here and read through the code, and you understand the output. They give us the same thing, but one is faster than the other. No loop is happening here. No loop is happening here at all. Okay. So reshaping arrays. How can we reshape an array? Right. I've seen reshape. Now for reshape, I'm just comment them. You pass in the array. Okay. You can do dot. Now one thing you can do is you can do dot. Let's say you want to save it in a new place. Let's just try something. Reshaped array. Let's say reshaped array. So you can do mp.array, mp.reshape, I mean reshape. Then you pass in the array first. So you can say, let's say we have an array. Then in a tuple, you pass in, where is it jumping out? In a tuple, you pass in the shape. That's 3, 2, or whatever it is that you want. Right, you pass it in this way. This is if, let me comment this out again. All right, so stop shouting. So this is if you don't, if you want to save it, if you don't want to overwrite what you have before, so you just want to save it this way. So you can pass in the array first. But the method we used before was array this way, then dot reshape. So if we're using it as a method, then we're just going to pass the shape of the array. So 3 by 2, right? We're passing the shape of the array. We did that just somewhere right here. I think to create, yeah, see it here. So just do dot reshape like that. So that's that. Now, what other thing is important for you to know about reshaping? Now, we can convert a shaped array to another kind of array. That's a flat array. But before we do that, let's say, for example, you just know the number of rows you want to convert to. You don't know the number of columns, right? So you want an automatic column. So you can do array.reshape, then you pass in the number of rows, right? As we always say, it is row first before column. So you can say 7 rows, then minus 1. Now this is a super method or a pro tip that you can use to convert, because before you can reshape a particular array, I mentioned it from the start that the shape you are passing, the product of the individual numbers of shape you are passing must be equal to the number of elements. For example, if you have an element with 15, if you have an array with 15 elements, you cannot reshape it to 7 by 3, because 7 times 3 will give us 21. You cannot reshape it to, let's say, 15. So let's say 6 by 2. So 6 times 2 will give us 12. Where should you keep the remaining 3 elements? Okay. So, but in cases like that where you don't know the number of columns you should reshape to, you can use the -1, the -1, to get an automatic column for your reshaping. So to flatten your entire array, let's say you have it as 2 by 2, you just want to take it to 1 by 1, all in a single row like that. You can do mp, I mean, dot ravel. Then you pass in the value or the matrix you want to reshape. That way, just pass it in like that, and then you reshape it. We also have np.flatten itself, np.flatten. So you can just say array dot flatten. Okay. You can explore the rest, like resize, resize, new axis, expand dims, and the rest. You just have them like that. But these are more like, okay, important ones that you should know, right? That you should know. So let's look at handling missing values. How to handle missing values in an array. Okay, handling missing value in an array. So we can use, let me just take this out. Let's create a simple array. Let's say bad array, bad array. So we want an array of mp.array. So we want 1, 2, 9, 7, 3. All right. So let's say this is what we have. And we want to be able to maybe undo the missing values, add some values to it, and the rest. Okay. Yeah, and of course you're already seeing that this has been highlighted, all the nans. Of course the nans will work, but we did not remember to put or to prefix it with mp. Okay, so mp should be mp.nan, 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 and mp.nan. Okay, so we can print. Okay, and I'm missing a parenthesis as well. Open and close. Okay, now let's print our let's print the bad array. Let's print the bad array. Print bad array. So you can see we have nan. So we have them just like that. So what if we want to check null value check? So we can say np dot is nan. Then we pass in bad array. Okay, so this should return a boolean to us where we can see true or false, true or false, true or false, true or false. Okay, you can see. Let's wrap it in a print. By the way, it works both for 2D array as well. So we're just using one linear array in this case to demonstrate it. So you can see the first one says false, false. It is not empty. But the third value is empty. False, false is not empty. False is not empty. Is not empty. It is empty. It is empty. Okay. So that is what we have. We can check that if they are empty or not. Okay. So we can now replace two numbers, right? For example, we can replace the value to numbers. So let's try taking the mean. Let's quickly see something. Mean of array. So do mp, let's print mp dot mean, and then we'll pass in bad array. Control enter, and we're getting none. So what if we do none mean? So we're getting number. This is why that when you have null values in that case, and you try to take a mean, because we're about to replace the values. That's what I wanted to show you before we do that. All right, when you take a mean, you get a none, because not a number. That's what none means, not a number. It's telling you, oh, we have some empty values that are not actual numbers in there. Okay, so what can we do instead? We can replace the empty values. So we can say replacing none values. Okay, so we can do a print, and then we'll say mp dot none to. So you can see that even Python uses the word and it's a function. If you look at it here, it is a function. So we can create a function like that in Python, but of course we already have one. We don't need to do that again. We can just do this, and then we'll say we'll pass in the bad array, and then we're saying none should be equal to, excuse me, here the none, excuse me, none should be equal to 0.0, basically 0, but since I want it in decimal or in float, right? That's the decimal here. So let's run this, and now we can see all the nans are gone. So if we try to take the mean at this point again, mean of array after replacing, now mean of array after replacing. Okay, so I can bring this, copy all of this, put it in here, and let's see if that's gonna work. You can see we're getting 2.63. Now let's take the mean regardless of the replacement, mean of array with safety, with non-safety. Non-safety. That means we're trying to bypass the non. So that's what non-mean. Non-mean. We're saying take the non, but exclude exclude the take the mean but exclude the non. Okay. So if we run this, now you can see the value. They are different. What is the difference? Now, why do we need a precise knowledge of what's going on at this point? It is very important. It is very, very important, because as data professionals, you cannot afford to find yourself in a situation where you cannot explain what you've done, especially when it has to do with numbers. You can't explain why you're seeing a number, right? It is important. Yeah, you're basically saying the data cannot be trusted, and you as the analyst cannot be trusted. So what is the difference between the safety part and after replacement? So I'll copy those value, and I'll copy this. So let me just paste it in here. Okay, no, I think this is for this hashtag. paste. Then I'll copy this, cut it instead, and I'll paste it here. Now, what is the difference between these two? For the one where we replaced the number already, what it is doing is it is taking 1 plus 2 plus 0 plus 4 plus 4 plus 0 again plus 9 plus 0 again plus 0 again plus 7 and plus 3. So basically, it is saying 1 plus 2 plus 0 plus 3 plus 4 plus 0 plus 9 plus 0 plus 0 plus 7 plus 3. Now everything divided by, I think we have 1 to 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 values, right? Divided by 11. That is what this first average is doing. While the second average, on the other hand, is simply doing, let me add a colon. Let me add a colon here as well. While the second one, on the other hand, is simply doing 1 plus 2 plus 3 plus 4 plus 9 plus 7 plus 3 again, excuse me, plus 3 again, all right, then divided by how many? 1, 2, 3, 4, 5, 6, 7. So the major difference is, as much as 0 is insignificant, it is part of the number. It is part of the number. So since it is part of the number, then it is counted as part of the number to divide with. Okay, so since it's part of the number, it is counted as part of the numbers to divide with. But in this case, since we are excluding zeros completely, it is not counting it as part of the numbers to divide with. I hope this is clear. Okay, so it is important that you have a clear distinction of what is going on. Okay, it's important you have a clear distinction of what is going on. All right, so what other thing can we do? That means we can replace none with the average of other values. So instead of replacing with 0, we can replace with the average of other values, just like that. So we can take a sum of this, and take a sum, and just say print sum of array, and say mp dot sum. We'll do this, we'll pass in bad array. If we run this, scroll down, you can see we're getting what? None, not a number. If this were to be Excel will intelligently discard them. But we have to tell Python that, okay, get the non-sum. And you can see we're getting 29.0. So let's put back the print. Okay, we're missing the print. Okay, one more bracket. Okay, so we're getting what? 29. And yes, we still have some numbers. For example, we can filter the non-values, right? You can just filter the non-values. How do we do it? The same method we've always used is the same way we'll do it. So we can just say bad array, open a square bracket, then in here we'll say mp dot is none, remember, boolean, open a bracket. What are we passing? Bad array. bad array. Now, if we run this, so we're saying, let's look at the code first before we run this. Okay, so we have bad array and our condition goes into a square bracket. That's the way we filter. Our condition goes into a square bracket. And what is the condition that we have in this case? We're saying is none. Okay. Now, if we print this, if we run this, this will give us the null values. So, but what we're trying to do is to, you can see we're getting none. But what we're trying to do is to get the real values. We want to take out the null values. So what can we do? We can negate it using the tilde symbol. So we're saying not none. That's just all this means. Can you see? The tilde symbol is saying not none. So if we run this again now, we can see we're getting the values that are not the values that are not what's it called? That are not empty. Yeah, that are not a number. The values are actually numbers, I mean, sorry. So we can also use where. Well, we can use where, and yes, this can also work. This filter can also work for the ones we have looked at before, and we can also do where. Okay, where can also work with what we want to do. So let's look at that, and then we just wrap it up from there. So filtering array using where. Okay, so we can say print np dot where. So now say, okay, open inside the bracket, then we'll say np dot is none a bad array. What do we want to do now? Inside is none, or inside what's it called itself, is none of passing our bad array. Then we'll say -1, then passing bad array, just like that. Okay, so let's run this. Is there anything missing? Let's run it. We'll tell if something is missing. Okay, what did I miss? I'm missing something right there. Oh, okay, yeah, this is where I'm missing something. Close. I didn't close this. All right, unnecessary brackets. Let's run that. Okay, so you can see we're saying where we have the missing values in this place, replace them with the -1. So although none have now been replaced with -1. So what if we want to replace with let's say mean, np dot none mean bad array. Okay, do not forget that this is how we're passing the bad array, right? We're passing the bad array. We're saying np dot where. So check for the missing the non values, not number values, replace with the mean of other ones inside this particular array. Okay, so you can see we're getting this. This is what we're now getting. So let's see how we can do 2f and then oops, not out. Then we'll run this. Now it is not letting us do that directly, so except let's try the curly brackets if that's gonna work for us. Curly brackets, curly brackets. So now it's not letting us do that. So let's just keep it this way. Let's keep it this way. And we'll run enter. And yes, this is what we now have. Alright. So we can now close this. But by the way, we already know why this didn't work. The simple reason why it didn't work is because we're not using a formatted string in this place. So we cannot use the .2f. Okay, we're not using a formatted string. All right, and yes, we've seen a good number of ways to undo missing values. So if you want to do for standard variation, just have to put nan std. But the best thing is check first. How do you check? Using is nan. Okay, using is nan. And once you check, you know what it is, then you can now move on to other things. And where is a good way to also replace a value as well. Okay, so where can also be used for filter. Okay, remember in SQL that is even the way we filter, right? Where something is this, right? Where something is this, because when we did it earlier for filtering, I think other basic operation, we thought that was fast. Basic operation, was it basic operation or before the basic operation? Then under indexing and slicing, so we can use where. So let me just leave it there as where. So you can use where, or should I say we can use where? It doesn't matter anyway. So yeah, so far we have covered pretty much everything we need to cover. Is this everything you ever need to know about NumPy? Well, it's an endless journey, it will be an endless pursuit of knowledge. The ones we need and the ones we don't need, right? If we say we want to know everything about it, but with this, you have a good understanding of NumPy. Okay, you have a good understanding of NumPy. The best thing is to start getting exercises, and there will be more exercises. Maybe video will not be made on them, but there will be exercises posted in the Telegram channel. So you want to get your hands on things apart from the ones that is appearing in the video. There will be more exercises that you can use, you can take up to practice. So if you have not joined the Telegram channel, the link is in the description below. Do well to join now. Okay, so let's look at the milestone exercise that you have. This is for you. So you're creating a 1D array for temperatures. You have this. You're creating a sales data with 3 rows and 4 columns containing any value of your choice. You are then assessing the elements, the second row, third column. You're slicing it, get the first 2 rows and all columns. You are using Boolean indexing to find temperature greater than 24. And then you're calculating the mean, median, and standard deviation of the temperatures. And with this, make sure you give this a good try. It's very easy and simple, just to test your knowledge of what you've learned so far. And yeah, with this, we can wrap NumPy, or Numerical Python as it's known, up or off. Okay, and for this and more, I'll see you on the next video. But till then, keep practicing, 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 and practicing.